Okay. This is very important topic. I seek your attention in the initial 5-6 slides for basic concept. So our topic is quality of service in 5G, and we will cover these topics. Protocol data unit session and quality of service flow, which we had covered earlier. We'll just quickly summarize. Then what is quality of service architecture in 5G? And in some slide, we'll compare with 4G. We will talk about default quality of service flow, guaranteed bitrate QoS flow. Then what is QoS rule, QoS profile, SDF template. We'll also talk about QoS flow in a network slice. What are different QoS type parameters, alternate QoS profile, 5QI, 5G quality of service indicator characteristics. What are the standard value of 5QI? So let's so this is based on specification 23.501. So you can also download and read. Perhaps I have also uploaded onto the team. Yes, we have discussed that now 5G we have a separate control plane and separate user plane, and the data traffic is always flowing through UE, radio access network, UPF, and then to the data network through the PDU session, which we had explained. And we also know that a PDU session is created with a default quality of service when a mobile is registered onto the network. And this particular PDU session, this particular quality of service default one is for the entire lifetime of this PDU session. Yesterday we had spoken about it, and then many other quality of service flows are added to support various type of services requiring different quality of service, and each of these QoS flows are identified by an ID. We call it QFI, quality of service flow ID, QoS flow ID, QFI. So every this quality of service flows is have an ID to identify, and this is the lowest granularity on which any quality of service will be applied in the 5G network. So these QoS flows can be established, added or removed within the PDU session, right? So for example, if some service this user is trying to avail, so a QoS flow will be added or modified, and later on when it has stopped using that, that can also be terminated. Now how so the 5 aspect. One is that once a device is registered, user equipment is registered, a PDU session has to be created, has to be established, and that PDU session is unique for the UE. That means that PDU session will only be used by that UE, and quality of service is enforced at the QoS flow level. The quality of service added for each service requiring different QoS. So QoS is enforced at the QoS flow level. And for that purpose, the packets either for the uplink direction or to the downlink directions, those are to be classified. That means filtered and appropriate QFI mark so that proper quality of service is applied across end to end. And then within the PDU session, you can have more than one QoS flow. So let's look at this on a pictorial view. So this is important. Please try to understand this. I'll spend a bit more time here. So this is your user equipment. This is our radio, we call it G node B, and this is user plane function, and after this you have a data network. Now let us talk about the air interface, the UV and G node B. So it is an air interface, radio interface. So onto the radio interface, how this quality of service, resources for quality of service are managed. So the yellow color cylinder which you see is your PDU session. This represents a PDU session. Now on air interface, resources are allocated. So those are called DRB, data radio bearer. So in this picture, you have this one radio bearer here, and this is another radio bearer, right? So this is on air interface side. On to between G node B to UPF. This is called N3 interface, if you recall. So here a single tunnel is created. That means one tunnel for one PDU session. A single tunnel is created, and this is the GTP tunnel. Yesterday somebody was asking. This is happening in user plane. So this is your GTP tunnel. Now let us talk about QoS Flow. So within the PDU session, onto the air interface side, you have DRB. So the DRB can support one QoS flow, or it can support more than one QoS flow. In our example, I have two DRB, this one and this one. In this DRB, QoS flow 1 and QoS flow 2 are being handled. In this DRB, QoS flow 3 is being handled. So it's a flexible that system can allocate one or more QoS flow within a DRB. But onto the N3 interface, that is between G node B and UPF, you have a single GTP tunnel. GTP is GPRS tunneling protocol, we call it. So there you have all the flows in a single tunnel. So this is the 5G QoS architecture from UV to UPF. This is a summary that a PDU session may contain multiple QoS flow and several DRB. There can be one DRB or more than one DRB, but a single N3 is the interface, GTP user plane tunnel. And also the DRB can have one QoS flow or more than one QoS flow. I hope this is clear. Okay. Now, how many types of QoS flow can be there? The types of QoS flow. Any question?
Sir, yes, sir. I have one question, sir.
Yeah.
So
please.
what is the significance of DRB, sir?
DRB are nothing but radio resources in terms of frequency and time. Okay. For every PDU session, you require radio resources, then only you can send the data. So those are called DRB. Terminology used here is here and also in 4G is DRB. These are nothing but time and frequency resources onto the radio.
Okay. Sir, one more question, sir.
Yeah.
So when this PDU session can be terminated?
So so your device is normally have two states. One is the active state, when you are actually latched to the network and trying to access data less or more, or you may be idle for some time, but you are actually active. So that means there will be a PDU session for you into the network. When you are inactive, right, then there is no requirement of PDU session because you are not trying to access any data. Okay.
Okay.
So whenever initially you switch it on for using the mobile, you do a registration and then try to access something, a PDU session will be created. creation of a PDU session is based on request by the UV itself, right? UV will request creation of a PDU session. Suppose you are idle, I mean, you are not using data and you don't have a PDU session. So UV will request a new PDU session whenever it want to access data. Got my point?
Okay, sir. Thank you, sir.
Okay. So there are many types of QoS flow. The first type is GBR, guaranteed bitrate type of QoS flow. The quality of service flow which requires guaranteed bitrate is called GBR. So some of the services will require GBR kind of QoS flow. And then other QoS flow type can be non-GBR, NGBR, right? NGBR, where the bitrate is not required to be guaranteed, right? And third is the delay critical GBR. Those services which are very sensitive to delay or latency, those are called delay critical guaranteed bitrate. And the fourth type is the reflective quality of service. Reflective quality of service is nothing but the quality of service applied onto the uplink side. Those rules are driven from a downlink packet. That means whatever quality of service was applied in a downlink side of the packet, the UV can actually extract those and apply towards the uplink direction. So that we call it reflective kind of type of QoS flow, reflective quality of service. So these four types, this reflective and delay one, the last one was not there in 4G. 4G was having this GBR and NGBR. This is also very important. Yesterday I was trying to explain this, so please understand. So this is about the quality of service rule, quality of service profile, and SDF template, that is also called PDR. Just understand that in the user plane you have UV, then you have G node B, then you have UPF, and then you have data network. And as far as quality of service aspects are required in the control plane, the AMF plays role, SMF plays role, and then PCF also plays role, policy control function. So here what you see that the QoS rule is for UV. Just understand, QoS rule is for UV. QoS profile is for G node B, the radio. And the SDF template or PDR rule, so other name is the PDR, packet data rule, is for UPF, right? So the QoS rule is nothing but information about how to filter various service data stream and apply a QFI, quality of service flow ID, QoS flow ID, right? So that a particular QoS is applied. So those are just a rule given to UV by SMF. So SMF is given to UV for a particular service. Similarly, G node B has to also apply quality of service. So they are provided QoS profile. So SMF provides QoS profile to Z node B. And the UPF is also required to classify various service stream coming in the downlink direction. So it requires also certain filtering rule. So those rules are also provided by SMF to UPF, right? So the QoS rule is for UV, QoS profile is for G node B, and SDF template or PDR is for UPF. So please make this clear first. And now the QoS rule and this SDF template, in a broad sense, they are just filters, right? They're just filters. They are enabling UPF and UE respectively to filter out a traffic and apply a particular QFI. But the QoS profile has got lot many other information and lot many aspect has to be taken care by G node B related to quality of service. Each one of them we'll talk about in upcoming slides.
Sir, one or two clarifications.
Yeah, please.
As far as this QoS rules are concerned, they are applicable in the 5G network. Now, data network may be, sir, internet network, maybe dedicated private network or any other different type of network. So, is there any counterpart available so that this 5G network can pass on these QoS parameter and they support it, or is there any work in that direction so that we have the networks which support the required quality of service?
So very good question. Very good question. So basically, you then may be knowing that quality of service in a normal IP world, they call it diff serve. You know that?
Sir.
You may be knowing about diff serve, through which various quality of service is managed on a normal IT network, right? Normal IT network. So there is a mapping. So suppose a QFI 1 or QFI 2 or 3 is there in the 5G network. So those will be mapped to corresponding in DiffServ also you have certain classifiers. So we'll be mapping to that.
Right.
Outside the 5G core network. So that schema is there and that has to be applied.
One, sir, more follow-up, just clarification. Before this UPF, left side of a UPF and right side of UPF when this data network is connected, what is the protocol? It is TCP/IP or it is something specific from left side and other right side is TCP/IP, or how it's developed?
So these tunnels are GTP tunnels, right? These tunnels between G node B and UPF is your GTP tunnel, and outside this, there is a specific interface created by 5G which is called N6. When UPF connects to the data network, it is basically N6 interface where specific protocols are defined. So it's not something else, but it is an N6 interface.
Then subsequently, then it has to be, when it connects to data network, it has to means
so it becomes a
translated.
normal IP world, right? Normal IP world. So they will handle it.
So which component of core network is doing this translation and from
UPF itself, no? So because all the user plane traffic will terminate, go through UPF. So the termination point is UPF itself.
Okay. Thank you, sir.
Right. Very good question. So the mapping which I talked about, that how the quality of service is applied. So this picture is directly taken from the specification document. So we call it two-step QoS flow mapping. Why two-step? Because there are two components. One is the UPF, another is the radio resources. So whenever from application layer, maybe YouTube or Netflix or any service data flow or service data flow is coming to UPF in a downlink direction. So since UPF will have PDRs, packet data rule or SDF template, so they will apply those filter rules and they'll come to know that this stream is coming from YouTube, or this stream is coming from Netflix, or this stream is coming from some service, and those rules will also tell that which quality of service has to be applied. So that QFI marking will be done at UPF level. This is the first step. Second step, when it reaches to the access network, now the mapping has to be done onto the radio. So where you have DRBs, right? You have one or more DRBs on which DRB, which flow will be moving. So the second step of mapping will be done at the radio level. That is in downlink direction, and similar is the process in uplink direction. Here the filtering is done by the user equipment using the QoS rule, and then you have radio network, and then you have UPF, and again it will go to the particular service, YouTube or Netflix or whatever. So this is called two-step QoS flow mapping. I'll explain it with a better diagram taken from some website. It was given. This is just an example. Consider this as an example, not the exact implementation. Exact implementation may differ. So, so different type of service data flow or IP flow, they have explained this is as an internet PDU, right? Best effort, maybe WhatsApp, maybe Skype, maybe YouTube. And then here Netflix is shown as a separate PDU, a separate service. Then a voice is also shown here onto the IMS, and video is also shown. So these are different kind of IP flows coming to the 5G core network. So UPF is shown here. So UPF, as I said, will have filter, PDR, packet data rules, or that we also call it service data flow template or traffic flow template, whatever name. So basically these are nothing but filtering rules. So based on these rules, it will apply the quality of service. So here you see that the best effort is given QFI 1. WhatsApp video and Skype is given QFI 2. YouTube stream is given QFI 3. The Netflix is given QFI 4. And voice is given 5, and video is given QFI 6. So this is how they map it. So don't consider that these are exact values. These are just an example, right? Now onto the G node B. From G node B to onto the air interface, there are DRBs. So suppose there are 5 DRB. So on DRB 1, only the QoS flow 1, where best effort traffic is going. DRB 2 is having your QFI 2 as well as QFI 3. DRB 3 is handling the Netflix stream. DRB 4 is handling your voice, and 5 is handling video. So this mapping, and then it goes to the user, and again it is segregated into respective IP flow. So it's a downlink direction. So this is how the mapping takes place. A generic example.
Sir,
Yeah.
when is this mapping created between the GTP tunnel ID and this DRB IDs?
So when a PDU session is created and a QoS flow has to be applied, as I said that all those rules are given to UV, profile is given to G node B, and the SDF template is given to UPF. So during the creation of the PDU session and applying a particular quality of service flow, these all rules are applied for that particular QoS flow.
Okay.
Let me explain you this.
Sir, in case of multiple node B scenario, this PDU session, when it will establish after conformity to the particular G node B, or from multiple
So
PDU session will be created?
you are right. So multiple G node B, you are saying that connecting through 2 access, that option you are saying?
Means
So
best quality is to be taken by a UE from particular G node B, and suppose neighboring G node B is also there and it is also sending signaling and
okay.
controlling.
Yeah.
So how
Okay.
it will establish PDU, which PDU will be taken off?
Okay. So basically you are talking about there is one UV, and suppose there are multiple G node Bs, right? G node B 1, 2, and 3, and UV is moving. That's what you are trying to say, right? And then
Right.
so suppose a data call is going through G node B1, so we'll have a PDU session already created, right? A PDU
Yes.
session already created where you have at one side UV, then you have G node B, and then you have PF, and then finally data network. So as I had explained that this UV continues to measure signal quality from 2 and 3, right? 2 and 3, and whenever signal quality of 2 or 3 becomes better, it informs this G node B handover process start. So at that point of time when it is getting handed over, so there is a switch over. So this portion UV to Z node B. Now the PDU session is same, only switching over from one G node B to other G node B is happening, right? One G node B to other G node B. So that switch over process will happen. So there may be a bit of delay there while switching over from one G node B to other G node B. Your UPF is remaining same. Your UPF is remaining same. So now the question is that continuity of that session. So session is getting continued, and there is also an option in the specification that it is possible to make the connection before switching over. So a smooth handover is also possible because the next connection with the next G node B can be made before breaking the connection with the previous G node B. That is also there in 5G. That's an implementation issue. I think I request to some of you, mic is on. Can you mute your mic? I request that you please mute your mic.
Sure.
I see a lot of. Let me.
ட்ரெஸ் பைய வச்சுட்டு வந்துட்டீங்களா? அதான் நினைச்சேன் நீங்க இது கொடுக்குறீங்களே அதை கொடுக்கலையேன்னு நினைச்சேன். இதெல்லாம் எங்க இருக்கு?
So shall I proceed? Shall I proceed?
Yes, sir. Yes, sir.
Okay. So let me explain you this particular slide. I want to talk about default QoS flow, and after that how a GBR QoS flow can be added. So when suppose your device want to access a data, or you are switching on your device, at that point of time, as I explained, a PDU session will be created, and at least a default QoS flow will be added. So this one, the green one, a non-GBR default QoS flow is added. And suppose you are using the best effort service like internet, so that service data flow is flowing through this quality of service flow, QoS flow. Now suppose, so this is a default QoS flow. Now suppose the device, same device, is trying to access some other service, maybe a video streaming service, So the system knows. So what your device does, that it talks to the application function which is offering this video service, that through this default QoS flow, that it want to access the video streaming. Now this application function which is offering video streaming will talk to the PCF and request that a particular quality of service is applied in respect of a particular UV. So finally PCF will instruct SMF, SMF will instruct UPF, and also give rule to UV and to the G node B. Then what will happen? One, a guaranteed bitrate QoS flow will be added, maybe on a separate DRB, and onto that one SDF, which is for video, will be added. Now suppose your device parallelly want to also access AR/VR service. So at that point of time, your system will again check. So what it will know, that the QoS flow which was added earlier, having the same quality of service parameter which AR/VR requires. It will not create a new GBR QoS flow, but the second SDF will be added there itself. So this is how additional GBR can be added either onto a new GBR QoS flow or within the same GBR QoS flow, multiple SDF can be added. So this is the concept of GBR QoS flow. Any question here or shall I proceed? Okay.
Sir, one my question is that how this delay critical is being taken care.
How this delay critical services. So there is yeah, please go ahead.
You have got my question, sir.
So I got your question that in case of a delay critical services, so for delay critical services, 5G has got a specific QoS requirement already built. I'll talk about that in upcoming slide. Your question will get answered.
Sir, one more question.
Yeah.
Sir, in case of offloading using Wi-Fi and non-3GPP non-trusted networks, how do you ensure the QoS?
Yeah. So next slide is for that. Just see this. This is an non-3GPP access. So as I said that here from UV to N3 IWF, the tunnel creation, IPsec tunnel I talked about, one was for control plane, other was for user plane. And then you have again GTP tunnel here. So here it is not concept of DRB, but a static IPsec tunnel getting created between UV and your through non-3GPP access up to the N3 IWF, non-3GPP interworking frame. So this is how the QoS flow, I mean the quality of service is taken care since there's no radio network in between, so it becomes easy, right? So on a radio network, you have to allocate resources and all. Here you're just creating the IPsec tunnel onto the wireless LAN or Wi-Fi LAN. And here, so you don't have much control here onto the Wi-Fi because suppose onto the same Wi-Fi, if you have connected n number of devices and every device is using data, so there will be limitation on allocating resources. And in case you are the only user, then there's no problem. Whole bandwidth is yours. So whatever limitation is there on or till the N3 IWF onto the GTP tunnel. It is inside 5G network, so they'll be able to take care of the resources. Did I answer your question?
Yes, sir. So this N3 IWF, it will be having a public IP, right?
So it has to, because if it is coming from non-trusted, then it has to connect.
Yes.
Right? Unless
Correct. Yes.
that is there, it will not work.
Right? Okay. Thank you, sir.
Right. So this picture I have brought in again. I just explained again somebody has opened the mic. Very okay.
Sir, do the IPsec tunnels also have quality of services different, or can the EPS quality of services or the 5G quality of services be applied there also?
No. Those IPsec tunnels are, I mean, just in pipe. So there is no specific handling. So their quality of service is in terms of how much bandwidth you are allocated to that IPsec tunnel, right? That is the only thing. And since that may be a shared resource, because onto your Wi-Fi there may be n number of devices connected. So you cannot really manage in a better way. But of course, once it reaches to the 5G core, you can apply whatever rule you have.
Because the same PGW will get selected. I mean, same SMF will get selected there.
Yes. So the most important part to handle in quality of service is on radio interface, right? The QoS profile, which I talked about, which is being given to the G node B. So what are those QoS profile? What are various parameters of the QoS profile So the first is the 5QI value. We call it 5G QoS identifier, 5QI. So there is a table of 5QI which I'll be showing to you. Then you have a term called ARP, allocation and retention priority. I'll discuss that. Then we have a attribute called reflective QoS attribute. Then we have some concept of notification control. And then we have a flow bit rates, guaranteed flow bit rate, maximum flow bit rate. And then we have aggregate bit rate, that can be session aggregate bit rate or UE based. So session number or UE number. And then we have maximum packet loss rate. So these are various parameters of the QoS profile which is given to G node B. So what are these profile? Let me explain you one by one. So the first is the 5QI. As I said, 5QI is a scalar, a number, and for every number, these are 6 various parameters. For example, whether it is in GBR or non-GBR or delay critical, what is the priority level of this 5QI, what is the packet delay budget, what is the packet error rate, and all these will be calculated in which averaging window, and what is maximum data burst volume. So these are 6 parameter of or 6 characteristics of a particular 5QI scalar. As I said, 5QI will have say 5QI 1, 2, 3, and every 5QI scalar will have value of these, which I'll explain you. Okay, so starting from one by one, let me explain you. Starting from ARP. So this ARP is applied at the SDF level, SDF service data flow level. So within the QoS flow, there are multiple services having same quality of service. So at SDF level, this level here, at this SDF level within the QoS flow. So suppose SDF or service is having low ARP value. So if some other ARP is being added, so which one will get the resource? The resource will be allocated to SDF, which is having the higher ARP value, right? So that is the concept of ARP, allocation and retention priority. At the time of allocation and at the time of retention. Retention means when suppose there are multiple SDF and some new SDF is getting added having higher ARP. So some of the SDF may be dropped. So those are retention priority. Okay. Now the next is the reflective QoS attribute. As I was explaining that in some case UV will not require QoS rule. It can derive the QoS parameter from the downlink packet. So whether UV has to apply reflective QoS or not, that comes in the attribute itself. So that is for reflective QoS. The next concept is about notification control. So suppose a QoS flow is running, say a GBR QoS flow is running, but what happens is that the system is not able to maintain that quality of service. Maybe the guaranteed flow bitrate which is required is not being maintained. So what your G node B will do, it will notify the SMF that I'm not able to manage the quality of service flow, right? And but it will still try to kind of maintain the quality of service, and suppose it is able to do it, so it will again notify the SMF that yes, now I'm able to provide the required quality of service. So this is called notification control, all because the SMF and other PCF core network must have this data so that if there is an SLA, those can be applied. If there are charging related aspect, those are taken care. So this is called notification control. There is also concept of alternative QoS profile. That means some of the guaranteed bitrate type of services may operate on different level of quality of service. So while sending those QoS profile, all those alternate profiles are also given. For example, a video on a YouTube can actually be played in high definition, can actually be played in very low definition. So there are multiple quality of service possible in a YouTube stream. So when quality of service parameters are profiles are sent to G node B, if there are alternates, those are also provided. So what happens when a G node B is not able to maintain the main quality of service, it tries to maintain the alternate in a sequence, alternate 1, alternate 2, alternate 3, whatever priority is given. And every time it notifies the SMF that yes, it is not able to maintain the quality of service, but it is able to maintain the alternate one. So all those notification and control are happening between G node B and the SMF, and SMF talk to PCF. PCF also gets notified. So this is called QoS, alternate QoS profile and notification control. This is the concept. Now there is a concept of flow bitrate. In a guaranteed bitrate concept, what is the flow bitrate? So bitrate within this QoS flow. So there is a concept of guaranteed flow bitrate. That much bitrate is guaranteed, but that is the minimum. So other thing is maximum flow bitrate. What is the maximum bitrate it can allow? Within this flow, the minimum and maximum both are defined. Minimum is called guaranteed flow bitrate and maximum is called MFBR. And this is applicable only in case of guaranteed bitrate type QoS flow. Now the next concept is aggregate bitrate. And the first parameter is the session number. So for an UV, within the session, there may be many QoS flow running, right? So what is the aggregate bitrate combining bitrate of all the flows? So that is called aggregate bitrate at the level of session. So this we call it session number, session aggregate maximum bitrate. So these are also defined for a particular service and particular UV. Now the next concept is the UV number. So UV can have more than one PDU session. As I was explaining in ATSSS kind of environment where the data can flow through both the access. In that case, there is a concept of UV number. At UV level, what is the aggregate maximum?
डिसाइड तो सेक्रेटरी कर, अगर सेक्रेटरी ने मेंबर्स को इंस्ट्रक्शन दे दिया या एएसटीज को सबको इंस्ट्रक्शन दे दिया, इस बार सीजन क्या हो गया?
So I just muted. Some noise was coming. So this is the concept of UV number. The next concept is maximum packet loss rate. So how much packet loss can be allowed? So this is also for guaranteed bitrate type of environment. And then you have 5 QI, those 5 parameters I talked about. So I don't know whether you'll be able to read those small things. So for example, this 5 QI scalar, first it has a number 1, 2, 3 and so on. And then it will have the resource type, this one, whether it is a GBR, non-GBR or delay critical. Then it will have a priority level. Here it's written 20, 40, 7. So every 5 QoS scalar will have a priority level. Then packet delay budget, how much delay it can tolerate. And then you have packet error rate, 10 to the power -3, -4 and so on. And then you have an averaging window. I mean, in how many period you will measure. So 2000 millisecond is your averaging window. And here it is a service type. It is a voice, it is a video and so on. For every service, there is a 5 QI value. And then you have for delay critical resource maximum data bus volume, that in a particular period, how much data must be actually transmitted in a for URLLC kind of services. Okay, so let us talk about resource type. So it is GBR, non-GBR, delay critical GBR. So this example is for GBR. The next was priority level. So priority level within the QoS flow, within the 5 QI, what is the priority level, which is given here 20, 40, 30. And then you have a packet delay budget, that how much delay in a packet is tolerated. For example, if it is in GBR QoS flow, so if the packet delay budget is more, that means we are not able to maintain guaranteed bit rate, then that packet may be considered as lost for a GBR kind of environment, right? The next is the packet error rate. So it's very simple definition that how much packet error can be tolerated. Those are defined as 10 to the power -4, -6, -8, depending upon different services. An averaging window is the window in which these calculations are done. So let me explain you the maximum data burst volume, and this is applicable for delay critical type of resources. So where what happens is that in a URLLC application, data rate may not be important, but reliability is important. So what happens is that suppose maximum data burst volume defined is 255 bytes and the packet delay budget is 10 millisecond. So it is expected that within 10 millisecond, this much data must be delivered. If this much data is not delivered, that will be considered as a lost packet. Even if it is received late, it will be considered as loss and will be counted here. So this is applicable for delay critical GBR. And these are a standard value of the 5 QI. This table gives, this is also in the specification for GBR, for non-GBR, and for a delay critical GBR. So this was what I was having. Any question I can answer. If you have